Hello friends. Today, starting from this video, we're going to give an introduction to automatic control systems or control theory, a course that goes by various names but is basically known as control. So, first of all, here's where we need to start. So, what is control? This is what we call control. It deals with the behavior of automatic dynamic systems. In other words, we can say that dynamic systems create a certain system and create a control mechanism with the automatic behavior of this system. Now, when we think about what is the dynamic system in the definition of this control, the dynamic system, if it is a dynamic system, is based on input and output signals. In all control operations, well, there's an input and, well, this input undergoes certain operations and then we get an output, well, as an output, friends. So, what is the signal in this definition? This time we ask, what is the signal? Well, when we ask what is the signal, we can express it as a physical quantity that we call time varying, which usually varies with time. For example, the position vector, velocity vector, temperature, component, voltage, current, and so on. These are the most basic definitions. Usually, dynamic systems have memory. This is another characteristic of dynamical systems that are in control. So how do we express dynamic systems? What matters is what I'll show you now. Dynamic systems. We can treat all these processes as differential equations. Well, of course, these transfer functions are also important for us. We illustrate with these. Well, if we take the dynamic system, one of the most important points for us is that we will do a lot of question solving and so on these dynamic systems. Well, what we call a dynamic system is based on a very simple logic. Of course, what creates the complexity at this point is the internal structure of the dynamic system. In general, there is a dynamic system. If we show the structure of a dynamic system as a dynamic system, we give an input to this dynamic system. This input combines with a certain disturbance, which is a signal that has a disturbing effect, to produce a certain output from the dynamical system. Now, when we neglect the input signals and disturbance signals in our calculations, we can get an output signal as we expect. But after the disturbance signals, which we call disturbance signals, come into play, we always get an output with a little bit more margin of error than we expect. In fact, this is one of the biggest reasons why feedback circuits are usually created in these systems, because feedback is also, well, about regulating the new input to the system by subtracting a certain margin of error and ensuring that the system receives the proper output. These feedback operations are one of the methods to eliminate these disturbance effects. After this intro, friends, we'll continue examining these dynamic systems in the following questions. In this way, we've introduced our control lesson. Hope to meet you in another video about control in another video in the same way. Goodbye for now.